Hi, my name is Eric Basier. I'm Senior Director of Product Marketing at Quantum. And as part of our series talking about building massive data stores with Quantum, in this short presentation, I'm going to be talking about the role of tape in hyperscale data centers. Now, tape has seen a big resurgence in the last few years. And in fact, the LTO program announced record capacity shipments in 2021. And you can see some of the comments from some of the press recently. One of the big shifts is that hyperscale cloud providers are now among the biggest consumers of tape storage. And they're using tape in a way that's different than the way tape has been used in the past. And I think there's something that any organization that is managing a large amount of data can take away from the way that these hyperscalers are using tape. And Quantum, we've established ourselves as the leader in providing tape to these hyperscalers. We have now 5 of the world's largest hyperscalers are in production. We've deployed over 40 exabytes globally. And right now we have over 3 million LTO tapes in hundreds of large tape libraries across hundreds of data centers. And it's enough tape that it would go to the moon and back 3 times if you were to stretch it out. So we're dealing with managing tape at just a huge scale, a scale that's never been seen. And what we're now focused on is how can we take our learnings from that architecture and kind of bring it to the enterprise or bring it to organizations that have a similar problem and pain point. Now, why do these large hyperscalers use tape? First, it's just the economics, the cost. I mean, tape is the lowest cost storage option. But beyond being just very low cost, it's got reliability over a long lifespan. Data kept on tape when, kept in the proper environmental conditions can be retrieved for, 30 years or more. So it's very reliable. It's very green. It consumes almost no power. Tape libraries consume very little power. And the tape media itself is inert. So it's low power. It's also, very little carbon emissions. And we've got a good roadmap toward capacity. And of course, it's very secure by its nature. It provides kind of that natural air gap to, help, make it more cyber resilient and help mitigate against cyber threats. What's changed is the way that which tape is being used. It's being deployed in new models now. And if we think about the old way and the way that many of us are kind of familiar with using tape, it was really all about tape maybe being a backup copy or a secondary offsite copy, right? It was primarily about backing data up to tape, taking the tapes out of the system, shipping them off to a vault, and that was the archive. And that had a bunch of downsides. It introduced tape handling, human error, and it's one of the reasons why in the backup world, many folks have migrated to new technologies. Now, the use of tape for massive data archives, it's different. Here we're dealing with mostly unstructured data, big files, big objects, and tape does very well with big files and big objects. It's exabyte scale, and what we're seeing is the new model would be where the tapes are actually kept in the tape system. They're kept there. So it's more of almost a nearline archive, or, tape is the new nearline in a sense. What it requires is new types of software, either file or object based, that abstract how applications interact with tape. And some of the more modern interfaces for that might be an object interface, either S3 or even like an S3 Glacier API or interface as a way to put objects to tape and retrieve objects from tape. So we've learned a lot through our journey, and I wanted to just kind of talk about sort of the learnings that we've had over these years. There were several significant milestones in our journey, and it started with back in 2017 was really our initial engagement with our first hyperscale customer. That's when we actually started to do some custom tape design work for tape libraries at hyperscale. As that progressed, we've had development summits at our executive briefing center in Englewood, Colorado, which is also our tape R&D headquarters globally. And we really have started to build now custom tape library designs for the hyperscalers. Notably, in 2021, we had our first multi-exabyte wins at web scalers that used not just quantum tape, but either quantum file system software or object software in front of that tape as a way to basically create an entire file or object archive. And right now we're working on co-developing the next gen hardware and software. So we've done custom library designs. We introduced cloud-based monitoring at massive scale. Think about thousands of tape systems, tens of thousands of tape drives and hundreds of thousands and millions of tapes, right, that we're all monitoring and helping to manage. We were really the first to pioneer what we call the rail architecture, and I'll talk more about that. That's a redundant array of independent libraries. We co-developed the hyperscale tape system. We introduced the first hyperscale design tape library in 2020 and 2021 with our Scalar i6H. And then in 2021, we introduced, kind of packaged together, our object store software with a hyperscale tape architecture so that we could bring Glacier class storage to the enterprise, right? And to these large data-driven organizations. And throughout this journey, we've had really three key learnings. And it's just that using, tape at hyperscale requires totally different hardware. So a more modular approach, we've improved the density, and even for serviceability, we've done a bunch of custom things to, enable things like one-side serviceability of the tape systems, and I think that's important for many large data centers. So it required totally different tape hardware. We had to invent different software, and right now our ActiveScale software operates at a much larger scale, and we've introduced innovations in the way that we can do erasure encoding to tape so that we can more tightly integrate our object store software with tape. And it also required us to really invent different ways to monitor and support tape systems and file and object archives at this scale, at an exabyte scale. So our cloud-based analytics software now, is being used by these hyperscalers, and we capture more data than ever before, and we're starting to use advanced machine learning and predictive analytics to help proactively identify things like tape drive failure signatures or tape drive and tape media failure signatures that interact with one another. So we can build data stores for the biggest environments in the world, and we've done it. We've built the biggest single archive that's ever been built by man, and we can now offer that and extend it to a broad customer base. We have everything from tape libraries, and we'll talk about how we can kind of put some of these building blocks together. We offer StoreNext file archives that can be sold with flash, disk, and tape, and our ActiveScale object storage software, which can be sold with disk and tape. ActiveScale is now the only object store that can be built on top of disk and tape. And bringing these together, we have our AI Ops software, which we call Quantum Cloud-Based Analytics, or CBA. This is monitoring software that runs in the cloud and can plug in or attach to any one of these systems. And of course, a broad portfolio of world-class support and services. So we can offer these as products, or we can offer it as a fully managed service like we do with our object storage services. I want to talk a little bit about RAIL, or redundant array of independent libraries. This is how we advocate deploying tape at hyperscale. It results in the lowest total cost of ownership, but also some other benefits like better density and a more modular footprint. Now, what RAIL is rather than deploy a single monolithic library, a tape archive can be deployed in rack-sized tape systems that can be, spread out across a data center. It doesn't have to be contiguous. This is kind of analogous to the way that primary storage is often designed these days. It's more of a scale-out architecture for tape as opposed to a scale-up. So here in this picture, we're showing 6 different tape libraries. Think about each one of those robotic systems as you've got pictured here, 6 robots. Now, instead of only having 1 or 2 robots retrieving tapes and that, you've got 6. So you've got an extra layer of redundancy. And because each module is smaller, it's easy to deploy. Capacity can be purchased in small increments, and it's less of a construction project to build out a massive, 20 frame tape system. So Rail has a lot of advantages, and this is how we're advocating tape archives will be built, over the next decade. So kind of bringing together what we can offer, we have a number of different ways we can engage with large organizations depending on your needs, depending on what your requirements are. If you're an organization that has developed your own in-house software, we can provide the tape. We have industry-leading tape systems, and we would do that with a quantum rail architecture. In this case, the customer would design their storage software. This is what some of the largest hyperscalers do because they've been willing to invest the time and the engineering resource to develop their own software stack. Now, we think for many organizations, they may not have the capabilities to do that in-house, and they may not want to spend the time. So we've got 2 software platforms we can use to be the front end to a tape archive. For a file archive, we would use our StoreNext file system software. This is StoreNext is a parallel file system, but it has very advanced policy-based movement between high-speed tiers of storage and to tape. So we can move directories and folders and files from, flash to disk. We can also move it to tape or to an object store system or the cloud. And we've developed that over many, many years working with a lot of clients in, research institutions and in HPC and many other, organizations throughout the world. More recently, we've introduced ActiveScale, and we've enhanced our ActiveScale software to be able to provide S3 compatible storage classes and lifecycle policies to read and write data to and from disk and tape. ActiveScale, we would advocate as really being the best for massive scale archives. And we use advanced, what we call 2-dimensional erasure encoding, along with the ability to Geo-Spread an object store system across 2 or 3 sites to get that, geo-distributed protection. So we've got a number of different ways that we can integrate and provide solutions for large-scale data archives. So in summary, we think tape has a bright future in terms of providing low-cost, long-term data storage in hyperscale data centers. And we think the next era of data is going to bring with it significant challenges around size. Many of our customers now are dealing with multiple exabytes of data, and tape can help solve that problem. It provides cost-effective and cost-efficient active archiving. And with the innovations that we've introduced, it's now very, very easy to integrate tape into your environment through a modern software-defined interface like a file system or an object store. And we've taken all of our learnings from providing tape to the hyperscalers, and we've packaged that together either as a product or as a service. So any large organization that has these requirements can now deploy tape easily and effectively within their own data centers. If you'd like to learn more, please visit our website on quantum.com, and thank you very much.